For us to understand Unit 4 Lesson 2 well, we do have to have gone over the Unit 4 Lesson 1. So make sure that you know how to apply the negative exponent and power of a power rule, because it's going to come up a lot. So negative exponent law says that if you have exponent negative n, then you're going to bring that down so that it's a to the n. So you're basically moving from the numerator to the denominator, leaving the exponent as is, but the sign will change. Whereas for power of a power rule, you're simply going to multiply the exponents. All right, so rational exponent law. Question 5. In the example below, what is the power you should raise the base on each side to get the exponent to disappear? So when I look at this first part of the question, I notice if I want to go from the first line to the second line, I would have to square root both sides to make that happen. If I want to go back up, I'm going to square both sides to make that happen. So, and meanwhile, the relation that I have between it is that, recall from last unit that when you have this square root, which looks like this, it's the same thing as if you write it as an exponent in terms of fraction. Where that comes from is from the fact that, well, there's a 2 there, an invisible 2 there, and whatever that number is inside, well, any number has an exponent of 1. So that's where it's coming from, okay? And so for the next one, let me just erase that. Oops. Okay, for the next one, I want to get from b to the cube root by, how do I go from there to there? I cube root, and I have to put that 3 there. And then, meanwhile, if I want to go back, I will need to cube both sides to make that happen. The relation I have between the two is, well, if I have something to the exponent of 1/3, well, that's going to equal cube root. And again, with the same idea, well, anything will have an exponent of 1. All right, question 6. Write the expression in another way. So if you have b to the exponent 2/3, it's helpful if you write this so that the numerator portion is separate. So I'm going to write this so that it says b 1/3, and then I'm going to put the 2 on the outside, the numerator portion on the outside, because remember, 2 times 1/3 is equal to 2/3. So I'm taking that numerator portion out. I can't leave a 0 on top of the 3 because then the whole exponent is a 0 in that case, right? So what I'm doing is separating the numerator portion. Okay, so I have, all right, so in another way, I can try to put it in that way that involves a radical sign. And so how I remember it is, well, that numerator is gonna stick on that exponent like so. Meanwhile, the denominator has to go where the radical sign is. The numerator, like every single number has a numerator as the exponent. So that's why it sticks right on top of that variable b. Whereas a denominator part of the exponent goes on the radical part because not all numbers have that part. Okay. Question 7. What is the rational exponent rule? Okay, so keep in mind you have a to the exponent m divided by n. All right, so that's the first part. That's one way you can write the exponent in fraction form. And so you have a. Well, remember the numerator goes right on top as the exponent part, but what happens is that the denominator part goes to that part in front of the radical sign. So equals. Okay, so I don't need the brackets, right? So I'm just going to have n, a, m. And so one way you can remember this is by drawing a flower. Okay, so in case you are a visual learner, so if you have m divided by n, the n, that is part of the root, and that's why it's going here. Okay, and meanwhile, the flower pot the flour, it's like flour power. And powers are over here on the numerator. That's one way you can remember it. On to 8. Rewrite the following in a different notation. Simplify if possible. Hint, if brackets or exponents are not there, insert them. So remember, from part 6, I'm going to separate this. I'm going to have 6. I'm going to write 1 over 7. And what do I multiply 1 over 7 to get 2 over 7? Well, I'm going to put the 2 and then on outside of the exponent. And rewriting that into the radical form, I have 7, the 6, and then 2 like so. It's like the 7 root, and then you have 6 exponent 2. Keep in mind it is wrong if you have it like this because you're writing your 7 too big. You have to make sure that you make the root number small. Next, so 4 square root of 2x5. So this 2 has an exponent of 2. And so I'm going to have 2, 1 over 4, and x, 5 over 4. Okay, so that's one way I could write it. Or keep in mind another way I could write it is by writing, well, all of that in brackets and then writing it with the 1 over 4 on the outside. Part D. So question C, I'm going to start by applying that 5 as the exponent on each part of the term. And so I get 3 to the exponent 5, a to the exponent 5, cube root that, and I get, well, I can rewrite that as 3, 5 over 3, and a, 5 over 3. So that's part C. Keep in mind I could have also just written it as 3a, 5 as a numerator, and 3 as a denominator as the exponents for the whole thing. Part D, I can rewrite this as 16 to the exponent 1 over 2 because I have square root. And I can write the next part as x7. Remember that radical sign, I can put that as a denominator, and so put that as a denominator of 2. So that's one way to write it. But what I notice is that, well, if I have the square root of 16, or 16 to the exponent of 1 over 2, well, keep in mind that 16 is a perfect square, and therefore I actually have 4x7 over 2. And another way I could have written it is that I have 16x7 all to the exponent 1 over 2, but this again simplifies, so then I would have gotten 4x7 over 2 anyways. Okay, part 9a. So for me to understand, for part 9a, for me to explain 9a, you need to have a general idea of what is the base. So for this example, the base is -7. That is what is being repeated. In this case, the 7 is the base. When you expand it, it's going to look differently because the bases are different. And for example, this will expand to -7 times -7, which equals 49. This will expand to -7 times 7 because this negative part is not part of the base. And so this equals -49. So this is my rough side work that I'm going to erase very soon. And so for this next part, I can't write it like so because this negative is not part of the base. So what I'm going to write is there's no brackets on the base. And so that negative is not part of the square root. So in other words, I have not that, but I have 49, which is part of the square root, and the negative is going to fall on the outside. Meanwhile, 49 is a perfect square. And so you have, what is the answer? The negative at the front will follow, and you get -7. Okay. Part B, we have -125 to the exponent -2 over 3. I am going to habitually kind of change it so that I don't have the negative right on the division line, but tilt it so that I'm forcing it to go to the numerator. So I know where is a negative going to be. Because if it stays on the division line, it might confuse you. Where is that negative going to be? And so when I rewrite this, I'm going to say, well, there is a negative within the base. So I have negative 125. I'm going to write that part first. Remember, the numerator goes right on that base. Meanwhile, the denominator goes on the radical sign. So this is what I have. But when I figure it out, I'm going to actually go left to right, even though it might be confusing at times. So if I can, I'm going to take the cube root of negative 125. And I can take the cube root of a negative number because, well, the cube root of negative 125, try putting your calculator or thinking about it mentally, and you will get negative 5. Because negative 5 times negative 5 times negative 5 is equal to negative 125. We just can't take square root of a negative number because we can never take the root of a number when it's an even number on this radical portion part. Okay, and so I have negative 5 to the exponent negative 2. And then I'm going to force it to be a positive exponent. How? By putting that into the denominator. Keep in mind my base doesn't change, but my exponent will turn to a positive. So it'll be a positive 2 as the exponent. And then next, well, I know what negative 5 squared is, and so it's simply going to be 1 over 25. So making sure that you are just changing the exponent, the sign on the exponent as you go from the numerator to the denominator. Okay. Part C, I have 36 over 49 to the exponent of negative 1.5. So I'm going to change that so that it looks like negative 3 over 2. So I have 36 over 49 to the exponent of negative 3 over 2. I write it one more time so that it looks right on it looks like it's on their numerator. So again, remember that you are going to put that 36 over 49. You're going to put that numerator right on top as the exponent, and then you're going to take the denominator as part of the radicand. I'm going to do my arrow so you can follow where I'm going, equals, well, square root of 36 is 6. Square root of 49 is 7. Put brackets and all to the exponent of negative 3. So next, I want to get rid of that negative exponent again. And how I do that is, remember, the numerator and denominator kind of switches where it was. So I'm going to have 7 over 6 to the exponent of 3 based on the negative exponent law. Okay, and so I have 7 over 6 to the exponent 3. So I have 343 divided by 216. Okay, to give you a further explanation of why 6 over 7 to the exponent negative 3 equals 7 over 6 to the exponent 3, if you already know the answer to this, you can skip this part. To walk it through, notice that 2 to the exponent 3 is equal to 8. So everyone agrees with that. So 2 times 2 times 2 equals 8. So if I apply it a little further, what does 1 over 2 to the exponent negative 3 mean? Well, keep in mind that 1 can be rewritten as 2 to the exponent 0 because anything to the exponent 0 equals 1. And then I can apply quotient rule. Quotient rule says to subtract the exponents of the base. So then you get this. 2 to the exponent 0 minus 3 equals, well, then you get 2 to the exponent 3. So from here, based on the quotient rule, I get that 1 over 2 to the negative 3 equals 2 to the 3. Well, if that is true, if in fact 2 to the negative 3 is equal to 2 to the 3, what can we say about its reciprocal? We could then say that then 2 to the negative 3, the reciprocal version of the one below, should equal 1 over 2, 3. So what we're doing every time is that if you have 6 over 7 to the exponent negative 3, if you understand what's going on here, then we are simply switching the numerator and denominator and then putting it as the opposite exponent, like opposite sign for the exponent. Okay. Part D, Part D, again, I'm going to rewrite it so that I have the -1 like so, and then division line. So I'm forcing that negative to the numerator. Going to rewrite it so that I have 8/27. Introduce the brackets. The numerator always goes on the exponent. Put that radical sign, and then put a 3 at the front. And so I'm going to apply it. Well, cube root of 8 is equal to 2. Cube root of 27 is equal to 3. Why is that? Well, 2 times 2 times 2 equals 8. 3 times 3 times 3 times 3 times 3 times 3 equals 27. So I'm just keeping in mind some common numbers that I have. So 2 to the exponent, 2 divided by 3 to the exponent of -1. Remember, for the negative exponent, all I'm doing is flipping the numerator and denominator, the places of where they are, and so I get 3/2. And I'm done for that question. Part E. So for question E, according to my product rule, I'm going to keep the base and then add the exponents. And this is what I get. Well, that is simply going to equal to 8/1/3. But keep in mind, I can rewrite that as 3/8 or cube root of 8. And with that kind of question, I know that the answer is 2 because 2 times 2 times 2 equals 8. Question 9F, I have the following. So what I'm going to do is I see that there is a 8 to the exponent 1/3 or cube root of 8. So I'm going to bring that to the top. And so I'm going to have 8 to the exponent -1/3 when I bring it to the top, because previously it would have been a positive exponent on the bottom, but if anytime I move my base with to the opposite place from where it was, so if it was in the denominator to the numerator, it's going to switch the sign of what it had. And so I have 8/1 plus 2/3 minus 1/3. And so I have, well, 1 is 3/3, and that's 5/3, minus 1/3 is 8 to the exponent 4/3. So don't be done yet, because remember, you have 8 to the exponent of 4, and then you're going to write that as a radical so that it's a cube root. And so you get, well, the cube root of 8 is 2, and 2 to the exponent 4 is equal to 16. Question 10. Simplify the following. Give a reason why you can't cancel x6 or divide 5/12 with 4. So I am going to do prime factorization for the first part so that I know where I'm going later with that 5/12, and I kind of did it on the side. But before I do that, as a first step, I'm going to apply that cube root to every single part. So I have 5/12 cube root of 3, and then cube root of x6 divided by a square root of 4, and then square root of x6. And what I'm noticing is that it's very awkward for me to put these and leave it like so. So I'm going to replace these. So because this looks awkward, and this in fact is x6 divided by 3, and this is also x6 divided by 2. Because remember, if I don't have any number in front of that radical sign, that's a 2. And so what I'm going to have is, well, the other part is going to equal to x2, because 6 divided by 3 is 2, and then the bottom part is going to be x3. I need my prime factorization so I can reduce that cube root of 5/12. Keep in mind, if it works out perfectly, I guess it's perfectly fine for you to cube root 5/12 on the calculator, but I still use a strategy in case it doesn't work out for making it work perfectly, like we've seen in Unit 2. So what I mean is, this is a case where it'll be cube rooted perfectly and you get a whole number, but what if it's not? Okay, so that's why I do my prime factorization steps along the side. So 512 splits to 2 and 256, 2 and 128, 2 and 64, 2 and 32, and you keep going. And what you're going to find is that 512 is made up of 2 to the exponent 9. And why is that going to help me is that, well, I can rewrite 2 to the exponent 9. And I'm noticing that my 2 to the exponent 9, which is 512, has a cube root of 3 in it. It's under the cube root, right? And it's better for me to write this as a fraction exponent, so I'm going to do that. And this eventually reduces to 2 to the 3. And 2 to the 3 is equal to 8. So all of this for me to get 8 over here. But in this case, you're able to use a calculator and just get that. But again, this is like the foolproof way. And then on the bottom, well, square root of 4 is 2. And that's simple. And so 8 divided by 2 is 4 over 1. And so as my final answer, I get 4 over x. Just because this all cancels out and I have 1x on the bottom. So basically, I wasn't able to cancel these out because we're not dealing with the same roots. Along the top, I have cube root, and along the bottom, I have square roots. So I wasn't able to cancel it out because that was the case.